There are 4 distinct points where specialized lines meet in any triangle. These are points of concurrency. Miss Lamoureaux wants a song, you see, about these points to pass geometry. The easiest of these 4 points, the centroid, is where the medians meet. They intersect the midpoint of each side. Originally from the vertex, the 3 meet at the centroid. 2/3 its length is from the vertex, is the center of gravity. Finding the coordinates of the centroid is real easy. Just take the coordinates of each of the triangle's vertices, add them up and divide by 3. That's where the centroid lies. It's where the medians meet. Angle bisectors meet at another point. They originate from the vertices. It's equidistant from each of the sides, all 3. It's called the incenter, cause it's in the center. Like the centroid, always inside the triangle. Here are some properties. You find the coordinates, find lengths A, B, and C, then multiply the lengths with each of the vertices. Compute the sum of all these 3, and then you divide by A plus B plus C. 3 altitudes each arise from each of the 3 vertices. They're perpendicular to each opposite side. It's called the orthocenter, not always in the center. If it's obtuse, it's outside the triangle, a corner of 90 degrees. You take the coordinates of one of the vertices, the negative inverse slope is perpendicularity with point and slope you solve for B. Find 2 lines, solve algebraically. Circumcenters are last point. It's where the perpendicular bisectors meet. 2 can lie outside the triangle. Just like the orthocenter, unlike the orthocenter, these bisectors do not go through a vertex unless isosceles. Use the midpoint instead of the vertices, then calculate the slope with perpendicularity with point and slope you solve for B, and use algebra to see where the lines all meet. We're near the end, and then we'll finish up with some special properties. These 4 points have collinearity. It's called Euler's line. If it's isosceles, if equilaterality, then the exact same points defines concurrency. Centroid and center, orthocenter of 3, circumcenter makes 4 points of concurrency. We're at the finish finally. I really hope that you enjoyed my parody.